Example 10. In triangle ABC, we're given that the magnitude of AB is equal to the magnitude of BC. So it's an isosceles triangle. Use vector methods to prove that if BD is perpendicular to AC, then D is the midpoint of AC. So we are given that BD is perpendicular to AC. And we know that for perpendicular lines, the dot product is equal to 0. And we're going to use that to help us. Okay. And then we have to show that D is the midpoint of AC. So in other words, AD is equal to DC. All right. So required to prove that AD is equal to DC. And let's have a look at the two triangles separately. If we can show that we've got AD equal to DC that way, we can show that D is the midpoint. Okay, so let's have a look in triangle ABD. So this is our left-hand triangle. And if I select my point A as my reference point, my origin, okay, I can get vector AB by saying AD plus DB, okay, and I can find my magnitude squared of AB, and that will be AD plus DB all squared, and I can expand that using my dot product so that I get AD squared plus 2 AD dot DB plus DB squared, and AD dotted with BD are my perpendicular lines. So since AD is perpendicular to DB, that was given to me, AD dot DB is equal to 0. So therefore I can say that my magnitude of AB squared is just going to be the magnitude of AD squared plus the magnitude of DB squared. All right, let's see if we can do the same thing with the other triangle. Maybe we'll go up here. Maybe I should shrink that a little bit. I've gone a little bit over and I want us to have a look at the picture at the same time. Okay, so now let's look in triangle CBD. Well, I can find CB by going CD plus DB. All right, and I can find my magnitude of CB squared will be CD plus DB all squared, and I can expand that, so CD squared plus 2 CD dotted with DB plus DB squared, and again I can say that CD dotted with DB is 0 because I've got perpendicular lines, so CD is perpendicular to DB. I can say that CD dotted with DB equals 0, so therefore CB squared, or magnitude of CB squared, is the magnitude of CD squared plus the magnitude of dB squared. Okay, so let's make that equation 2, and let's see if we can find a way to relate those. In what we were given, we know that AB is equal to BC. So therefore, AB squared must equal BC squared. Okay, so our magnitudes, if our magnitude of a number of a line is the same, then the square of that magnitude is the same. So therefore, I can say equation 1 equals equation 2. So therefore, AD squared plus a DB squared is equal to CD squared plus dB squared. The dB's cancel, and therefore the absolute value or the magnitude of AD squared is the magnitude of CD squared, that's a C. And if our magnitudes squared are the same, then the magnitudes are the same. And so therefore AD has to be half of AC, and D is the midpoint of AC.